Hey, hello, and welcome to today's GFG problem of the day. Hope you all are doing well. So let's see today's problem. Count all paths. Okay, all possible paths. So what will be given is we'll be given an undirected connected graph. Okay, consisting of n vertices and connections between them. That is the edges. Okay, and we'll be given an adjacency matrix rather than an adjacency list. Okay, we'll be given a matrix. Your objective is to determine whether it is possible to start traversing from a node X, and we should be able to return to it. Okay, after traversing all the vertices at least once and edges exactly once. So we can traverse given a vertex, a single vertex more than once. Okay, but the edge should be traversed. Each edge should be traversed exactly once. Okay, so let's see some quick examples, right? So let's say if we are given a graph, right? Okay, this is the graph, and now, okay, now this problem, right? This problem is purely like you need to observe some pattern. Okay, if you are able to observe the pattern, then it is going to be very easy to solve the problem. Okay, so let's say this is a given graph, and we start from this okay node from this node. Okay, so we visit this two, right, and then we visit three, we visit four, and we visit one again. So that means we are able to reach the node one, right? Node one again. So that is we started from some node X and we are able to reach the same node again, right? And adhering to the conditions, right? We are also able to follow the conditions. That is we are visiting each edge exactly once and each node as well. Here we are visiting exactly once. Okay. So we are adhering to the condition. So we need to return one when it is possible. If we are able to start from a node X, and if you're able to reach node X, then we need to return 1. Okay, else return 0. So now let's make this example a bit complex. Okay, so here I add another node and an edge. Okay, so in this case, let's start from node 1. We started from node 1, we visited node 2. Now when we start 1, we visit node 2 to node 5, right? Now there's only one option to go back to node 2, right, from 5. But here we are violating the condition. We are visiting the edge twice, right? We are visiting the edge twice, and here they're saying that edge exactly once. Okay, so here we are violating the condition. So this we need to return 0. This it is not possible. Okay. Second condition. Let's take another example quickly. 2, 3, 4. Right. The same example with some modification. Let's say we have another 5 and 6 here. Okay. 5 and 6 again. Okay. Now yeah. So now we start from node 1, right? Node 1, we visit node 2, right? From node 2, now we have two options, either to go from here, right? Or visit this. Let's say we visit this one. We visited node 5, then we visited node 6, we visited node 3, right? This one, this one. Now we have again two options, right? If we go here, definitely we are not going to reach to node 1 because, right, we'll be going in a loop, right? We'll be going in a loop. If we go here, let's say 4, and we come back to 1, right? But here, if you see, this edge remains unvisited, right? So we are violating the condition again. This edge remains unvisited. Okay, and if we visit this edge, then again we'll violate some other condition. We'll be traversing this edge again. If we come from 3 to 2 and 2 to 1, again we'll be violating the condition, right? So this also in this case, we have to return 0. Okay, now let's make some observation, right? Let's make some observation. So initially when we had this graph, right, this graph, right? So if you observe, each vertex has even number of edges here, 1, 2, right? From 1 there are 2 edges, from 2 there are 2 edges, right? From 3 there are 3 edges, and from 4 there are 4 edges. So whenever this is a case that each vertex has even number of edges, then in that case we are able to reach to the node. For example, let's take quickly one more example, right? 3, 4, right? This is the case. And let's say we make a bit complicated again. This is the case, right? This is the case. Okay, this is not, let's make it here. Okay, so yeah, now we start from year 1, right? We go to 2, we visit 2. Okay, now we visit 5, we visit 6, then we visit 2 again, back to 2. So we are visited vertex 2 twice, but that's fine, right? That's fine. Now we come here again, 3, we go to 4, and we go to 1 again, back to 1 again. So here we are able to start from node 1 and come back to node 1 again. And we are also following all the conditions. We are not violating any conditions. See, each edge has been traversed exactly once, right? We are not traversing any edge more than once, right? And we're also following the condition, right, that each vertex is traversed at least once. That is more than once, right? More than once, one or more than one. Okay, so yes, each we have traversed each vertex as well. So in this case, if you see, right, there are even number of edges. From 1, there are 2 edges, this and this. From 2, there are how many edges? 1, this is the edge. 2, 3, 4. So again, even number of edges. From 2, there are 4 edges, right? From 3, there are 2 edges. From 5, there are 2 edges. From 6, there are 2 edges, right? So this is again. So it is possible. Okay, it is possible. And you observe each node has even number of vertices. Okay, now again, coming to this, right? Coming to this, now two had three edges, right? One, two, and three. One, two, and three. Three edges, and that is why. See, in this example, it was not possible to reach one, right? To reach one, okay, without violating any condition. So it was not possible. So here also from two, right? From two, see, in this case also it was not possible, right? From two, if you see one, two, three, there are three edges. Now you can take this vertex as well from one, two, three. There are three edges from three as well. So that is so. So yes. So in this case also it was not possible. So the observation is from each vertex there should be even number of edges, right? Then only it is possible. If any vertex has odd number of edge, then it is not possible to reach. Okay, to reach the start and the end node. Okay, the start and the end node. Okay, so here if you see quickly, so we are given an adjacency matrix. So what is a matrix? For example, it 1, 2, 3, right? These are the nodes, right? 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So 1 to 2, right? 1 to 2. So 1, right? 1 to 2. That means there is an edge from node 1 to node 2, right? 1 to 3, there is an edge from node 1 to node 3. So this is the adjacency matrix, okay? The representation of the graph. So if you what we are simply going to do, we are going to iterate each row and we are going to count the number of ones basically. That is the edges. One means edges, right? So here it is 4. Here it is 2. Here it is 2. Here it is 4 and here it is 2. Okay? So that means this matrix, right, has even number of edges, has all the edges which are even, right? So this means it is possible. We'll return one. Okay, so let's quickly see the code. The code is extremely simple. Okay, here is a code. So we start the first. We'll see the Java code followed by C++. Okay, so here we start. Okay, the outer row, right? This is the row for loop, and this is a column for loop. So for each row, we are going to calculate the number of edges. That is the number of one, right? So here, if you see, right, we are for each row we are calculating the number of ones, right? So here, okay. So once it is done for a row it is done. We are checking here. If the number is odd, simply return zero. Else return one. So this is a simple solution. Quickly, let's see. Almost same, right? The code. Let's see the C++ code. It is almost same. Again, yeah, we'll be given vector of paths over here, and yeah. So as I said, the code is almost same. Let's run this code. So yes, it is accepted. I hope you have got the solution. Please subscribe to my channel and like the video. It will motivate me. Have a happy, healthy, and a great day. Thank you so much.